Welcome to today's web conference, U.S. Azure Partner Community Call for April. I'd like to turn it over to your first presenter, Nick Johnson, National PTS for Microsoft. Nick, you now have the floor.
All right. Thank you, Kim, and welcome, everyone. Thank you for investing some time today with us. We've got a great call planned for you. And on behalf of myself, Nick Johnson, Frank Campisi, and Jonathan Gardner, your national PTS team, we're just thrilled to have you here. We've also got two guest speakers lined up that we'll get introduced to you in just a moment. So when we do that, one of them is going to take us through a new readiness tool, and then we're going to take a deeper dive and take a look at SQL and Azure and hopefully equip you to make some good choices in guiding your customers in a decision of how and where to store data. At the end, we'll leave some time for Q&A, and if we get to your question during that, great. If we don't get to it, please feel free to just post it in the chat window, as Kim mentioned. We'll be happy to take it there. And then we'll send you off with a few closing thoughts at the end. So thanks for your time. With that, I'm going to get out of the way, and I'm actually going to turn control over to my friend Steve Looper, and Steve's going to take us through an exciting new tool that he's been leading us into. Steve, it's yours.
All right, very good. Let me just grab the slides here. Good morning and good afternoon. Nick, appreciate you giving me the time on the call today. I know many of the folks on the call, as I used to be in the U.S. subsidiary, but I have now moved to the Worldwide Partner Group, and I'm the Worldwide Technical Lead for Azure Managed Partners. So I collaborate very closely with Nick and Jonathan and Frank around Azure things in the U.S. Specifically, Frank is sort of my partner in crime. Frank Campisi is my partner in crime on this catalog that I'm going to tell you about and show you about this morning or this afternoon, depending on where you are. Just quickly to tell you about the need, and truly I only have 2 slides, so I'm going to show you the 2 slides and then we'll do a quick demo, and if there are any questions, happy to take those. Just a couple of years ago, we heard from partners that there wasn't enough readiness material around Azure. People said they couldn't find what they were looking for, it just didn't exist, and so on. And these days, what we're hearing from partners is that there is so much readiness material on Azure that they don't know where to go to find the readiness material that they're looking for. So the idea of the tool that I'm about to show you is that we want to solve that problem. We're not trying to create new content. We're really trying to give you a place to go where you can find readiness information on Azure. And just to quickly tell you, we want to be very transparent with this, tell you about our requirements and our approach. First and foremost was our core principle is that unlike a number of things that you may have experienced if you've been partnering with Microsoft for a while, we don't always operate as quickly as might be ideal. So the core principle for our tool is that we want to operate at the speed of the cloud. We want to be agile and we want to be responsive to you, to our audience who this tool is intended for. Of course, we wanted to build it on Azure, so it's a website that runs on Azure. Today, it's mostly built for a desktop browser, although it's responsive and you can use a smaller browser or probably a big phone maybe, but we don't yet have true mobile rendering or mobile apps or anything, but that's the intent. And I guess I should say it is a catalog. It's really a catalog of readiness material from a variety of different sources, but rather than any one or two or even a handful of people maintaining that catalog, it's a trusted contributor and crowdsourced approach so that people can put in the things that they want, almost a Wikipedia model. People can put in things that they would like to expose to the community. And that's really the gist of it. So website, catalog, tool, crowdsourced, that's kind of what it looks like. So let me show you. First, and somebody will have to let me know that you can see my browser here. First, I want to make sure you have the URL to the catalog, to the tool. So as soon as the screen comes up, maybe Nick or Kim, you could confirm that you're seeing it okay.
It's in the process of loading into the console right now, so we'll just talk really slow until it does, and we're seeing it now, so go ahead, Steve.
Okay, so what I've got on the screen now is the URL for the tool. It's aka.ms/APRC, the Azure Partner Readiness Catalog. And so when you click on that URL, you're going to be taken to a very simple site. This is the home page. All of the entries in the catalog are here. You could scroll through them forever and ever if you wanted to. Well, maybe not forever because we only launched 2 weeks ago, and today we've got 160 entries in the catalog, as you can see at the bottom. But that grows every day and every week. We have a bunch of trusted contributors today who are all Microsoft employees, and we're looking to grow that. Down the road, later this calendar year, we might add MVPs, we might add P-sellers and the like. But in its simplest form, it's just a big list. And if you see something that's interesting to you, for example, coming up later this month, there's an MVP virtual conference. You could click on Read More and get more information about that conference, or you could click on the link and it'll take you right to that site. Of course, you don't have to read more if you can get everything that you need from the description or the keywords in the listing. You can just click on Go to Content and it'll take you right to the site for that piece of content. So that's the simplest way, as you can just see there is a list. Now, of course, if you're interested in particular things about Azure, you can sort and filter and search. So if I am just interested in something that's Azure Virtual Machines, I can click on the feature drop-down, select Machines, and then click off of it. And we'll see that today there's 24 entries in the catalog. And as I say, month by month, we expect that to grow pretty quickly. But 24 might still be too much. So maybe I'm just interested in content that is type video. So I can select type and go to video, and we see that it narrows it down to 10 currently in the catalog. And maybe I'm feeling pretty good about Azure Virtual Machines, so I only want content that's 300 technical level. So now I've narrowed it down from the entire catalog down to 8 entries that are interesting to me that specifically have to do with Azure Virtual Machines. But since Steve told you that the catalog is ever growing, you might want to come back and execute this query again in a week or a couple weeks. So you can actually just copy this URL, maybe even go to another browser and paste that URL in, and that's your saved query. So everything that I just did with that query, I can paste that into another browser window or save it, and it's going to execute that same query with the type, the technical level, the feature that I selected. Now, what I didn't show you yet is, of course, you can type in query terms. So if I clear the search and I just want to search for, I don't know, Hadoop, so I can type in Hadoop, and we find today in the catalog there's 5 entries, and as I showed you before, you can see the keywords, the technical level, and you can click on Go to Content to take you right to that entry. Or if you've got a favorite presenter or subject matter expert. You know, there's a guy named Keith Mayer who does some great content. So I can type in Keith, and we see that he's here as a keyword on one of these entries, and maybe he's listed in the description on another one of these entries. So that's the gist of how it works. Pretty simple catalog. As I mentioned, it's just 2 weeks old. It launched at the very end of March. We're adding content regularly, and we're listening to your feedback both on adding new entries to the catalog as well as adding new functionality to the catalog. Remember, I said this is for the audience. We want to be agile. We want to operate at cloud speed and deliver to you what's interesting to you. So there will be regular updates. As a matter of fact, we're planning another update before the end of April, in time for the Ignite conference at the beginning of May in Chicago. If you have things that you'd like us to add, whether it's an entry in the catalog or a functionality, you can just click on Contact Us at the bottom of any page, and you can give us feedback on a feature request or an entry that you think should be in the catalog. So that would be one call to action, is take a look at the catalog and give us your feedback. And the other call to action is just go visit it. So again, here's the URL, aka.ms/aprc. Take a look at it. Tell us what you think. Tell us how we can improve it. Look at it today and then look at it again in a couple weeks, because there will be new entries and new functionality before the end of the month. So that's really what I wanted to share with you. Nick, do we have any questions about the catalog?
There haven't been any typed in the window yet, but anybody who has a question, feel free to type it in. We can always take those offline as well.
Okay, sounds good. I'm going to stick around in case any questions do come up. I'd be happy to answer them. Of course, we're very interested in your feedback, want to know if it's useful and usable and how we can improve it. Of course, how we can improve it quickly so that you can get the most out of it. So that's all I have. I'll turn it over to Tony now so that he can have much of the balance of the time for his topic.
Great. Thank you, Steve. And while Tony's getting ready to share his stuff, let me just introduce him real quick. And Tony's a guy who we saw present at one of our internal conferences recently, and we thought, boy, this would be a great topic to bring to our partners as well. And so we invited him to come, and he graciously accepted to spend an hour with us here. So very excited to have him with. And really, it's all about understanding SQL and Azure and how do those things go together? How do you make choices on which platforms to be on, and what are some of the things you as a partner should be aware of when you're engaging with your customers. So very excited to have Tony here, and we're going to get him all set up. And then Tony, you're ready to go. Let me know, and we'll kick it off for you. You're still on mute, Tony, I think, if you're talking.
Tony, are you there? Ladies and gentlemen, one moment while we get our presenter online.
Right. Well, excellent. So this is Tony. I work in a SQL organization. I've been here about I don't know, 7-8 years, mostly focusing on the cloud, but other parts of SQL as well. And today I'd just like to talk about what we're doing with SQL Server in general and how it applies to cloud and SQL in a VM and SQL DB and the various form factors of the SQL we have. So one of the good things to start with usually is just telling people how it is that we approach the development of SQL Server, just so you get a good idea. Because a lot of people think that SQL DB, Azure Sequel DB, is something different than SQL Server, and it's a different product. And where in fact it is only just SQL Server. We have one single source for SQL, SQL Server 2014, and the next version of SQL Server, which will be out, and SQL DB and the SQL images that you find in Azure VM Gallery are all built off of the same code base. We just happen to have switches in our product that allows the product to know which form it's running on, whether it's in SQL DB or it's in a box version, and it enables certain features, disables certain features as appropriate. So with recent releases of SQL, we've also moved to a cloud-first development model where all the features which you're working on, everybody in the SQL organization, all the developers, basically work on features, new features that they come up with, and once the features are completed, we actually release the features in cloud first, in Azure Sequel DB, and every once in a while there's a version of the box product which is built from the same source, which inherits all of the features. this is a major shift for us, because in the past, what we were doing was you had the box product and then we tried to get the stuff over to the cloud. But now it's just one place, and features show up in the cloud and then they show up in the box product. This is actually a good thing for our box customers as well as our cloud customers, because cloud customers get this stuff as fast as possible, and the box customers, by the time they get the new version of SQL, the features have already been there. They've been used by lots of people, and there's a level of awareness of the features. So when you get the new release of SQL, you kind of hit the ground running. So that's our mode of operation for building SQL. And as I said, we have SQL Server on-prem. We have the Azure SQL virtual machines and SQL DB. Those are our main SQL offerings. So the difference between, of course, these, it all comes out to who controls what. In the case of SQL on-prem product, of course, the customer owns everything. They own the network, they own the storage, they own servers. They have full control over the entire environment. We have on-prem customers who decide when exactly to upgrade the firmware on their SAN, right? So, and there are some applications and some businesses where you need that level of control, and those applications run on-prem. We have lots of customers who are no longer interested in managing data centers or the networking infrastructure and storage and so on. So they prefer to deploy SQL in a VM where they control the operating system, they control the middleware, they control the instance of SQL, the databases, and the application. And this is basically the box version of SQL Server. The same exact thing you would install on a machine at your enterprise, and the same you could deploy in a Azure VM. And we are always working on curating the best configuration for SQL Server in Azure VMs. So when new versions when new sizes of Azure virtual machines come up, there's always a SQL image that takes advantage of it. And we have SQL images that are specifically configured for OLTP, SQL images that are specifically configured for data warehousing. And you just go to the virtual machine gallery and you pick SQL Server and deploy it, and off you go. So that's the middle column for us. And then the last column is Azure SQL Database, where the customers are saying, look, I don't want to manage operating systems, I don't want to manage virtual machines, I don't even want to manage the instance of SQL, I just need some databases. And we have some customers that land in all three. We have some customers that are in the middle, we have some customers that are on the left, we have some customers that are on the right. So when do you go, what is the right choice for each workload, and where do you go? Do you go to the left, do you go to the right? It all has to do with the application type. So it's kind of important to have some idea of the purpose of SQL DB. When we wanted to go build Azure SQL Database, we decided that we wanted a real database where we had the transactional and consistency semantics of a true RDBMS. So we weren't trying to build a key value store. We weren't trying to build an eventual consistency store. In Azure, we have those products. We have Document DB, we have Azure Table, we have Azure Blob. Our purpose was to go build an RDBMS specifically. But we want this thing to be to have the characteristics of a cloud. So we call Azure SQL DB a cloud database service. And when we talk about cloud database service, as soon as you say the word cloud, there's a certain characteristics that comes to mind. So everyone you talk to, when you say cloud, they think it never goes down, there are no scheduled downtimes, it's resilient, you don't have to do backups, you don't have to worry about the data center, and there's infinite scale. Whenever you talk about service, people immediately think of those companies that provide good service, where they take care of their customers, where if you have an issue with your bill, you can call someone and they resolve it for you. All the normal things which you associate with a good service. And in the middle, it's an RDBMS, so it has all the features of a database. So that's what we wanted to build. And so for Sequel DB, it is elastic scale, it has performance, it has business continuity, it has data protection, and it meets the characteristics of the cloud service. But at the same time, it's your familiar SQL, same set of tools that work with SQL, and that's when you come into program to an RDBMS, you don't find something different. So that's what we set off to go and build. Now, what we have today in SQL DB, there's some million some databases that we manage in Azure Sequel DB. On any given day, there's about 350 million logins that happen, like people connecting. We have a customer that has 114,000 databases. That's a single customer. We have another customer that creates about 60,000 databases a week. They also delete some databases every once in a while. And we're in 133 different countries. And we basically bill about 20 million database hours per day. So it's a pretty big system. We're in all the data centers that Azure has. So wherever there's Azure Sequel DB. And when you look at the customers of Azure Sequel DB, this is one of the easiest ways to actually figure out what are the triggers for any one customer in choosing Azure Sequel DB or SQL running in a virtual machine or an on-prem SQL. Well, the on-prem stuff is really easy. People who need full control and of the entire environment, either for compliance reasons or whatever other regulatory reasons they might have, they go into on-prem world. In the middle column, which was the virtual machines, what we see is a lot of customers go to the virtual machines who basically have an existing application. They have no interest in changing the application, and they just want to lift that application and move it straight over to Azure without changing anything. Now, I'll give you an example. Like there's a feature in SQL Server that allows the database to share data with files that reside on the disk drive on that OS which is running SQL Server. And you can go modify the files, and those modifications show up in the database. And you can change the data in the database, and those modifications shows up in the file. And this is a mechanism that's used by a lot of people who maybe have data that comes from, let's say, a manufacturing assembly line where some industrial machines dump data into a file, and that data then shows up in the database directly. This is a feature which would not make any sense in an Azure SQL Database PaaS offering, because in a PaaS offering, the customer has no access to the operating system. It is a PaaS offering. The customer doesn't control the OS. So that wouldn't work. The scenario doesn't make sense. And that's a feature that is not in SQL DB because we can't give access to the operating system files in a PaaS service. But if you're a customer who has an application like that, the chances are you're going straight to the VM. So that's a good example of where you would go to a VM. Now, the examples of when people go to Azure SQL DB, there's some fascinating case studies there. One of the things we see is people who used to write software, and they were ISVs, and are now transitioning from selling licenses or software to individuals who buy the software and install it to becoming a SaaS vendor. These vendors now are faced with the fact that they are the provider of a service, and they have to manage the entire service on behalf of, let's say, 5,000 customers. And if each of their customers used to have a database, and now when that moves into the cloud, that all aggregates in one place as 5,000 databases. So here you have a customer who all of a sudden needs 5,000 databases, who used to be an ISV selling software, became a SaaS vendor, and their customers moved to the cloud, 5,000 databases, one per customer. Now, that is an environment which is difficult to manage because of the sheer numbers. And most of the ISVs that are in this category, they're not really expert in managing IT infrastructure in the first place because they used to be software vendors, not operational teams. So these are also the customers who are most likely to go to SQL DB immediately because they have no interest in figuring out how to install and manage hundreds or thousands of VMs and instances to manage thousands or tens of thousands of databases. And on the left, you see some companies that are pretty well-known ISVs, some of them. Sage is the 4th largest ERP provider in the world, and they're in Azure, and they use SQL databases to host the software for their customers. And again, Sage had no interest in setting up the infrastructure necessary for managing tens of thousands of databases, so they use SQL DB for that. MYOB is the customer with 114,000 databases. They're an accounting software company in Australia and New Zealand, and they have a database for every customer because they don't want to mix data from different customers into the same databases. So every time they get a customer, they have a new database, and that adds up, so 100,000 databases. Esri is similar ISV. They have thousands of customers around the world, and every customer has a database, so Esri has tens of thousands of databases. And these are use cases where they go straight to SQL DB. Even if they have to rewrite the application in some ways to accommodate cloud and adapt to the cloud, that's worth it to them, because alternative is much, much more painful, which is set up the infrastructure necessary to manage that many databases. So that's the column on the left, the ISVs and SaaS vendors. In the middle column, there are a number of enterprises that use Azure SQL DB, and they basically are writing new applications or augmenting their existing applications to run in the cloud because they're trying to provide a new service. And because the service itself is in the cloud, naturally they have a tendency to go to the cloud. So for example, Aviva is an insurance company in UK. They sell life insurance, car, property, all kinds of insurance. One of the products they have is that if you want a car insurance and you're willing to install an app on your mobile device that keeps track of your driving behavior, they're willing to give you a discount based on your driving score as determined by this app. So you basically install this app on your mobile device, you get in your car and you drive, and the phone navigation app that they have in this figures out where you are, whether the speed limits, whether you're a safe driver or not, and gives you a score for your driving. And as your score improves, your insurance rates go down. Now, this is a company which is completely in an on-prem world. It's a traditional insurance company. But this element of their application, which is a bunch of mobile devices, collecting telemetry from hundreds of thousands of people driving around the UK, having to upload that data somewhere, this is the stuff that doesn't go into the enterprise, because it just, the possibility of opening up their enterprise to a bunch of mobile devices is a security risk. So all these mobile devices call web services in Azure, and ultimately these web services consolidate and aggregate this data and stuff them in SQL databases. The data gets processed in SQL databases, and then ultimately this data is transmitted back to their on-prem systems where the actuarial software is running that actually determines the rate for an insurance for a person. So this is a system where it's an augmented existing application with an element of cloud. And Aviva had no interest in, again, managing a set of infrastructure in the cloud for this. So naturally they go to SQL DB because it's just easier. Somebody like Samsung, They sell a lot of TVs around the world. All the TVs are internet enabled. As soon as you buy a Samsung TV, you turn it on. It wants to go register itself. So these TVs around the world make a web call to Azure, again, to complete the registration of this brand new TV that somebody has purchased. And ultimately, that registration data ends up in a SQL database. That's how Samsung manages the software updates and firmware updates for their TVs that customers have. Now, the interesting thing about this case is purchase of TV and sales of TV is a very irregular sort of a business. So in the U.S., 25% of the TVs sold in U.S. is sold during the week before the Super Bowl. So that's a tremendous spike in capacity requirement. So what Samsung does is that they add more databases during periods where they know their sales are going to spike. And sometimes they can't really tell when their sales are going to spike, so they reactively go and add more capacity. So again, to do this on-prem is really difficult. To do it in a VM requires you to set up new VMs or upgrade VMs, which sometimes could take a while. But using Azure Sequel DB, they can spin up databases and they can increase the resources of a databases, instantly. So that works pretty well for them. And then on the last column, again, we have some customers with more traditional enterprise application that have added some element of social or some element of cloud, and basically they augment and modernize their applications. Now, something like the Samsung app, it didn't exist 10 years ago or 5 years ago when you didn't have internet TV. So that's a new application, and it was developed on Azure SQL DB in the beginning, where something like EasyJet, which is an airline, that application of selling airline tickets has existed a long time. So some of the elements now have moved to the cloud. So this is the type of customers that we have, and this should give you a good idea of how and when customers choose to go to SQL DB versus SQL in a virtual machine. And usually the database count is a very, very good indication. If you need one database, you could run that database anywhere. If you need 1,000 databases, the problem is much, much harder, and the tendency is to go to SQL DB. So hopefully this gives you a quick understanding of how the customers end up on SQL DB. Now, we recently released a new version of SQL DB. It's called SQL Database version 12. SQL Database version 12 is already GA'd in January in Europe, February in US, and now it's worldwide GA'd. It's available everywhere. And the idea here was to improve the compatibility between SQL DB and SQL Server. And as I mentioned earlier, there are some features that were not available in SQL DB because those features either didn't make sense in the cloud or they required some work in order to make them cloud friendly. For example, there were some features of SQL Server, when they generate errors, they dump the errors in the file in the operating system. Well, in the cloud, that doesn't work because how does a developer access the error logs in a file in an operating system? So we had to do some work to actually clean up some of these features of SQL Server so that they can scale and work in a cloud service. And as we have done that, we've enabled these features. So a lot of these features got enabled in version 12. Things like CLR and all of the indexing functions and XML and so on. So as we have launched SQL version 12, SQL DB 12, the demand on it has been incredible. A lot of people are moving to it because the entry barrier is a lot easier because you can run more generic SQL code and you don't have to mess with the code to make it SQL DB friendly. And this has worked out pretty well for us and for the customers, because when we went into SQL to build SQL 12, we had these goals, which was pretty much make SQL Azure DB compatible with SQL Server 2014. And also improve the performance. So one of the things that SQL DB v12 is that we've moved to SSD based machines. So your premium databases are now all running on SSD drives. So you get lots of I/O, you get lots of low latency I/O. We have some new architecture for the service itself, so better replication, better availability. And we've moved to the SQL 2014 core. This is where the cloud first thing comes in, because now the code which is running on SQL DB is the newest code in all of the SQL family, and this is the code which ultimately will go into the next release of the box product. So this is some random smattering of the improvements that we've made. Better database manageability. We've removed a bunch of limitations and restrictions on sizes, so things are a lot more manageable. We've enabled a number of the programmability features. We've introduced a lot of performance functions. And on the performance front, you'll see that like parallel query, we've enabled clustered and non-clustered column store indices, which is an in-memory technology, which is a SQL Enterprise Edition feature. But if you look at some of the other features, you'll see that in SQL DB, we've enabled some features that in basic, standard, and premium version of SQL DB, which are Enterprise Edition only on the SQL Server box product. So it's important to remember that the mapping of the features for the box product isn't the same as mapping of the features in the cloud. So for example, you can have table partitioning in a basic Azure SQL DB database, which is $5 a month. And that feature is an Enterprise Edition only feature in the SQL Server box product. So it's kind of important to not make assumptions what features are available. You gotta have to check the documentation here. So there are some features which are not available in SQL DB, and this is a good way of looking at it. So server configuration options, which are things about configuring SQL Server itself. These are managed by the service. So the customers can't manage these aspects of the server because we manage it for them. Again, this is a PaaS service. Anything related to replication and disaster recovery and backup and restore, all of that is built into the service, so the customers don't have to do it, so those are not enabled. And then some of the other issues, some of the other features which are not enabled, anything that spills out of a database, like cross-database, multi-database activities are limited in Azure SQL DB. So I'm going to pause for a second and ask if there are any questions as I've been going through. Do we have any questions, or should I keep going?
Let's see, there is a question here. In SQL DB, have they made any or more administrative functions available via SSMS? The SSMS GUI. Sorry, yes. I'm trying to read this real time.
Yes. So the answer is yes. If you go to the SSMS CU6, that's cumulative updates number 6 of SQL Server 2014 version of SSMS, you will see that a lot of the features of SSMS that were disabled for SQL DB are now enabled. And again, we're going to this model where we will have more releases of SSMS to correspond with the speed that we're moving in the cloud as opposed to the box. In the past, SSMS was tied to the box. So it came out every once in a while when there was a new version of the box product, and anything we did in between didn't work in SSMS, and now that has switched. So we will be releasing a new version of SSMS again somewhere around late May, which will enable more features. So the parity in SSMS has improved as well.
So a follow-up question to that is, can the on-prem SSMS be used to interact with objects in SQL Azure?
Absolutely. There's only one SSMS. So the SSMS, there's only one. So the SSMS for SQL DB, SQL Server, and SQL in a VM is the same SSMS. We'll just be releasing that SSMS more often, so people could use the latest version of SSMS. And usually the latest version of SSMS will work with older versions of SQL Server and the latest version of the cloud.
Sounds good. And then one more follow-up to that. Will the SSMS be offered as a native app in Azure at any point?
Actually, SSMS itself uses the Visual Studio shell, and if you go to the Azure portal today, there is a button that allows you to launch Visual Studio, which is the SSDT, for managing databases and the objects in the database. It has all the functionalities. So you could launch that from the portal today. And a lot of functionality is actually being built into the portal, and we'll probably continue to improve that for like query editors and such built into the portal itself. SSMS is a Windows application, so it's not going to fit in the portal, but the functionality will be surfacing through SSDT, Visual Studio, SSMS, and more of that functionality will move into the HTML portal as well over time.
Sounds great. Thank you. That's all the questions we have in the console right now. So if anybody has any additional, feel free to type them in, and we'll take some more in a few minutes.
Okay. So one of the questions people ask is like, okay, you've done a lot of work, so the compatibility of SQL DB and SQL Server and the SQL in the VM has improved. Well, what's not there? So this is the definitive list and the complete list of all the things which are not in SQL DB. So, and what you'll see here is that there's a lot of stuff which is work in progress, but some of this stuff doesn't make any sense. For example, Windows authentication is not supported in Azure SQL DB because Windows authentication makes no sense in Azure. What we have in Azure is we have Azure Active Directory and federation with Azure Active Directory. And so that is what we will be enabling soon in the next few months, where you'll be able to use AAD to authenticate against SQL databases. There's another feature called file tables. This is the feature where you share data between the database and files on the operating system. That feature will never be enabled because that is the world's largest security hole for a PaaS service, and we would never enable something like that where customers have access to the operating system. They can affect change in the databases. So a feature like that is really just limited in the environment where the customer has full control over the entire stack. So when you think about SQL Server is a server product, and a lot of time it does things which is way outside the boundaries of a database or the instance. So for example, you can interact with the operating system through SQL Server, and those are the features that are just not going to be in the PaaS service. However, most of those features are not programmability features, and some of them have equivalents in Azure. Like if you need notification, there's notification in Azure. If you need something like Service Broker, there's a Service Bus service in Azure. SQL agents, there's Azure Automation. So some of these things, there are alternatives in Azure. But anyway, these are the few remaining things which we don't support yet, and you can see some of them that we're still working on. Things like full text search, that's work in progress. It'll show up in memory. OLTP will show up, and so on. So I'm gonna cover some of the service features quickly. So in Azure SQL DB v12, we have 3 types of databases. We have basic, standard, and premium. The SLA for all of them is 4 nines. Basic is for light transactional workloads. Standards, medium transactional workloads, As you can see, as you go from left to right, the things get bigger and more resources and more precision in how resources are provided. And basics are limited to 2 gig. And a basic database is basically $5 a month. I don't know, it's a pennies a day. So, for, I guess, a lot less than a cup of coffee. I think it's like 8 cents a day or something. So, all of these databases, they come with a point-in-time restore capability. Because Azure Sequel DB is a PaaS service, there's no need to do backups for the purpose of protecting yourself from accidental errors or accidental deletions or what we call an oops recovery, like you made a mistake. We do backups every week, every day, every 5 minutes. The backups are pushed to replicated blobs, so even if the data center is destroyed, the backups survive and you can restore your databases. And with point-in-time restore, the benefit you get with point-in-time restore, you can basically restore a database to the exact point in time with seconds or milliseconds granularity. So let's say you discover that you made a mistake at 10 o'clock in the morning and you deleted a bunch of data, and you want to go back to the previous version of that database as of 9:59:55 or 9:59:59, 1 second before you actually made that mistake. Well, you just restore the database, and you can do this through the portal, or you could do it through PowerShell, or you could do it through REST API. You provide the parameters, and we go and restore a database to an alternate name, and your database just shows up. So without you having to do backups. So point-in-time restore is available for basic, standard, and premium. They just have different retention periods based on the type of the database. We also have standard Geo Replication, which is available for standard databases and premium databases. So if you want to protect yourself from disastrous, catastrophic events that could wipe out an entire data center or entire region, you can replicate your database. It's an asynchronous replication. It just continuously replicates the database to an alternate location. And in the case of the standard, the replication always happens to the Azure region pair. So north goes to south, east goes to west, Amsterdam goes to Dublin. It always stays within the geopolitical boundaries. So the data never goes outside of the political boundaries. So the US data will always be in US. We also have this thing called active georeplication, which is available for premium databases. With active georeplication, you get the ability to replicate your databases to 4 different alternate locations of your choice. So you can decide to replicate a database from north central to US, north central US to Japan, and Australia, or wherever you want. We don't have any restrictions or limitations there. And you can also use these secondary replicas for read workloads. So for the purpose of reporting or query processing, that's also available. For basic data protection, this is the summary of the features that we have. For the oops recovery, we have point-in-time restore and accidental database deletion. You can get your database back. And we also offer geo-replication for asynchronous replication that continuously replicates the data. And in case you don't want to pay for geo-replication, but you still want to have a disaster recovery solution, because all our backups are stored in Azure blobs and Azure blobs themselves are replicated, we're able to offer a geo-restore. You can restore a database anywhere on the planet. So if you have a database in Chicago and you want a copy of that database in Japan, you can just go and restore that database, and the restore target server can be in Japan, and that database will get restored there. So in case a database, in case a data center is destroyed or is no longer available for whatever reason, you can go restore your databases anywhere else that you like. And Geo-Restore is basically free. You don't have to pay for Geo-Restore. The only thing you pay is that when you restore a database and the new database is created from the backups, that database then you have to pay for. So those are some of our data protection capabilities. We also have an auditing feature where you can audit all interactions with the database, and all of the audit data is then stored in an Azure storage account of your own, and you can keep that data forever. You can analyze it. There are tools and templates for analyzing the audit data. So if you want to know who ran what query when, or who inserted data or who deleted the database, you can always go through your audit records. So again, I'm going to pause here for a second and see if there are any questions.
Thanks, Tony. We don't have any questions in the chat window at the moment, so if anybody has any, feel free to enter them now. Otherwise, if you want to take a few more minutes and wrap us up, that'd be great.
Okay. So this is just a summary of the various offerings, so standard, basic, and premium. Basic databases come in one size. Basically, with Azure SQL Database, what you pay for is not the gigabytes of the database. What you pay for is the performance level. So we have switched from selling gigabytes to selling guaranteed performance. And guaranteed performance comes in the form of resources. And the resources to run a relational database is read I/O, ability to write to the log, ability to do processing by using CPU, and memory. Those are the four elements that are required for database processing. Each of these databases of the different sizes come with a fixed amount of resources that is guaranteed, that is not shared with anyone. There's no noisy neighbors. There's no somebody else is on the server doing something and you're not getting your resources. The resources are guaranteed. So for basic, we have this notion of these resources called DTU, the database throughput unit, and it's a way of getting a relative performance figure. So basic comes with 5 DTUs. In standard, we have S0, 1, 2, and 3. S0 is 10 DTUs, S2 is 50, S300, and then in the premium we have P1 at 125 DTU, P2 at 250 DTU, and P3 at 1000 DTU. You can think of a P3 as a pretty big machine with lots of memory and CPU, something along the line of a D series machine in an Azure VM with somewhere around 8 cores and 50, 60 gigabytes of memory. So those resources are guaranteed, and you see the prices. Those are monthly prices. However, we charge by the hour. So if you create a database and the database exists for 1 hour, you just pay for that 1 hour of the database use. And just to quickly cover this DTU business, again, as I said, a DTU is the measure of the resources available to the database. It's a bounding box of resources, and it covers the CPU, read, write, and memory, and then you can see the various sizes of the DTU. And then you can get all of this information, how many DTUs you're consuming. You can go to the portal and see the graphs of the resource consumption, and there are dynamic management views that show your CPU budget and how much of that budget you're consuming. So all of the normal performance stuff that you usually expect. A couple of things that are coming soon. Transparent data encryption, or TDE, will be announced shortly. So this will be available. So all databases, you can encrypt your databases. We also have dynamic data masking, which is now in public preview. Dynamic data masking, you can mask information, and it's done by the database. So if you want to turn social security numbers to XXX and only show the last 4 digits, you basically define this policy in the database, and the database does the masking, as opposed to an application having to do this, because sometimes people make mistakes in the application and you get data leakage. And then finally, row-level security, which allows you to secure rows and not just tables and databases, where you can imagine like a nurse has access to the data for just the patients which they're working with, and doctors can see the data for all the patients that they're working with, and so on. So you can secure data in different ways. So this is some of the features that is coming up soon. Again, the idea is you got a service which is managed and secure for applications. So again, I'll pause if there are any questions to take.
Yeah, there's 2 questions that came in.
All right.
One is if a application or a user starts at a basic database level and they want to upgrade, how easy is it to upgrade that in Azure?
It is super easy. You can do this by going to the portal, and you just basically click configure, and you pick the next whatever service level objective that you want. The change is completely transparent and online, so there's no downtime, there's no disruption in your workload. What happens is you pick a basic and you say, okay, I want to turn the basic into an S3. And then underneath the system, a database copy is created in a place where it has the resources for an S3. And during this process, your workload continues and there's no interruption. And then at one point, we switched from the little one to the big one, and then everything just resumes. So there's no downtime at all involved. You can go from basic to P3. You can go from P3 to basic, as long as you're not violating the size requirement. So for example, if you have a gigabyte database, you can go from basic to P3 and back to basic. If you have a 500 gigabyte database, then you have to stay in premium because that's the limit. But you can go from P3 to P2 to P1 and P2 and P3, and you can make these changes online.
Good, thank you. And then I think you covered this mostly, but any good resources for helping sort of translate what a DTU is into common language for customers who might be thinking about it?
Yeah, actually, it's one of the highest requested pages that shows up. There's a bunch of blogs and the description in our Azure documentation specifically covering the subject. So if you just search for DTU Azure Sequel DB, you will see a lot of material, and you want to go to the Azure.com and there's a description on that. Azure.com is a good place to start for most of the Azure SQL DB stuff. All of the SQL stuff is documented the same way as SQL, but in Azure.com there's additional material that covers Azure SQL DB for things which are not necessarily boxy.
Perfect, thank you. And that's the end of our questions, and I know we're getting right up to the end of our hour here, and I want to be cognizant of people's time. So with that,
right. So just let me close by saying, so SQL DB for workloads that need lots of databases, new workloads, cloud-born workloads, SQL VM for lift and shift stuff where you don't want to change the app, and SQL Server for anyone who wants to remain on-prem. That's it.
Great. All right. Well, thank you, Tony, and thanks everybody for joining us. As you leave, just one quick reminder that there's a survey link in the window if you wouldn't mind to fill that out. Let us know how these calls can be more helpful to you. And secondly, we've got upcoming is Worldwide Partner Conference in July. Just a note that the full conference pass price goes up next week. So if you're thinking about going, get in at that low price today so that you don't miss that opportunity. And so with that, I'll turn it back over to Kim to close us out.
Great. Thank you, Nick. Ladies and gentlemen, we hope that you found today's information helpful. If you enjoyed today's web conference or have feedback on how we can provide you with a better event, please let us know by completing our survey. Please click the messages button to find the survey link, and the survey is on a scale from 5 to 1, with 5 being the highest score possible. Partners may access the web conference recording via a follow-up email that will be sent out 72 hours post-session. And I'd like to extend a big thank you to our presenters, Nick, Tony, and Steve. This concludes today's web conference. You may now disconnect.